Okay, let's quickly answer this question where you have up to four forces acting on a particular point or a particular body to keep it in equilibrium or in stable position. So let's do this. The question says the net vertical force in the diagram above is the net vertical force. So now this is how we're going to do this. We are going to resolve the forces that are not in a straightforward direction. What I mean straightforward, like you see this 25 Newton is in a straightforward direction, that's due north. This 20 Newton due south. And then but this 30 Newton is going both northwards and eastwards. So we're going to resolve these ones that are inclined at an angle. So let's proceed. So for the vertical force H, vertical, we use Y. Let me use Y to represent, will be equals to, if you come to the first force here, 20 Newton, you have to resolve this 20 Newton into its vertical component. And vertical component, we always use sine, not cos. Is when we are resolving to horizontal components, we use cos or cosine. And then the angle must be with respect to the horizontal. That's the force or vector, the angle made between the force or vector and the horizontal. So if the angle was to be on top here, like that of 45, resolving in vertical would have been cos, not sine. But to avoid confusion, the angle is given on with respect to the vertical. Then that means you have to do your calculation 90 minus that angle to give you the one that has to do with respect to the horizontal. So now to resolve this 20 Newton, that would be 20 sine 60 plus 25. We will not resolve 25 because 25 is already in vertical. It doesn't share any direction. But if you insist on resolving it, that will be 25 sine 90. Sine 90 because 25, the angle it makes with the horizontal is 90, and sine 90 is 1, which will still give us 25. So no need of resolving it, but we still keep it there. Then this other one, the third force, will be 30 sine 45. The sine 45 I'm talking about is the one with respect to the horizontal, not this one, because 90 minus 45 will still give you 45 here. So I'm not wrong there. We have not done. There's another force here. This one is going downward in opposite direction to all of them. So that will be minus 20. So if you process that, 20 sine 60, that's 20 times sine 60 is a special angle. So that will be root 3 over 2. But if you have calculator to process this at once, that makes it easier, you get your answer. But if you are writing a kind of exam that you don't have calculator, that we are not permitted with calculators that do this, that will process this. So you follow the route I'm taking now. So this will be plus sine 90 is 1, so 25 times 1 is 25. So that's it. Plus 30 sine 45. Sine 45 is 1 over root 2 times 1 over root 2. Then minus this 20 here. So equals to 10 root 3 plus processing the like terms, 25 minus 20 is 5. So I'll write plus 5 there. and then this one plus, if you rationalize 1 over root 2, that will be 30 times root 2 over 2, and 2 will cancel that, 15 equals, what we're left is now is 10 root 3 plus 15 root 2 plus 5. So this is the lowest form you can simplify this Newton. But since this exam, you still use a calculator that can do basic things like finding square root. So if you process this, you end up having 43.53 Newton. And if you approximate that, you have what? 44 Newton, which is option C. So we have answered the question. So, but we can take the question further by saying also find the net horizontal force. The horizontal force, I represent it H, will be equals to, now the first one here, 20 Newton, will be resolved in its horizontal. That will be 20 cos 60. The next one here, which is 25, if you resolve it, it will be 0 because it doesn't have a horizontal component, it's directly on vertical. Okay, even if you insist and say let's resolve, okay, that will be plus 25 cos 90, and cos 90 is 0, so it will cancel. So we move to this one, that of 30. 30 will be minus. The reason is that it's in opposite direction to 20 with respect to horizontal, left to right. So you see this one is going this way and this one is going this way. So that will be minus 30 cos 45. Then this other force here, down here, 20 Newton, has no component in the horizontal. So if you resolve it, to give you 0 there. So no need to waste our time. So this will be 20 times cos 60 is 1 over 2 minus 30 cos 45. 30 cos, that's 30 times root 2 over 2. So if you finish processing this, you have minus 4.14 Newton. So that is the net horizontal force. But you ask, why is it minus? The reason is minus, what the minus here shows is that the force acting towards the right side is greater than the force acting towards the left side. So normally I should have started, it should have been 30 cos 45, then minus this. But it's still not a mistake, because if you still solve, you arrive here. What this shows is the direction that is in opposite direction. So that means if we are to draw our net vertical and horizontal force, of course vertical here was, the resultant of the vertical was 44, which means it's upward. So we draw upward. And then this one, negative 4.14, it means it is on the right side, not on the left side. So we draw towards the right. So this one is 44 Newton, and this one is approximately 4 Newton. So that is our net horizontal force is 4 Newton. Is 4 Newton. So if you take the question further and say find the resultant of all this, let's find that one singular force or vector that will give the same effect as all these ones acting together. Then we are going to draw the hypotenuse there to the right angle triangle we formed, and then find R. And you know R will be equals to square root of 44, that's using Pythagoras theorem, plus plus 4 squared. If you process this, your final answer will be 44.8. 44.8, which is still approximately 44 Newton. And if you were told to find the direction of the resultant, so you put there our resultant. So our resultant will be equals to, it's still 44, still approximately 44, still 44 Newton approximately. And then if you were told to find the direction theta, then you find a trig ratio that will relate these two known sides, and that is tan. That means tan theta will be equals to opposite of adjacent, that's 44 over 4, which equals to 11. And then theta will be equals to tan inverse of that. Tan inverse of 11, which will give you 84.8 degrees. So that's the direction. So maybe I took the whole thing too far. So we've answered the question since, which is option C. So these other ones is just to get more elaborate knowledge in case you're writing a theory exam that is more demanding. Alright, subscribe, like, share for one-on-one tutorial or group online tutorial. You join my WhatsApp. The link is in the description. Thank you.